Hi, I'll go through SMO Junior year 2025, round 1, question 1 to question 5. Question 1. There are two semicircles. We need to find the area of the shaded region. From this intersection point P, we draw the two line segments, PO and PO prime. Since PO prime and OO prime are radius of the semicircle, so this triangle POO prime are equilateral triangle. Angle POO prime is 60 degrees. This shaded region is made of two parts. One is this sector with the angle 60 degrees. The other one is this minor segment. Okay, so this sector, area of this sector equal to 60 over 360 times area of the circle, which is pi times 2 square. For this minor segment, its area equal to area of this sector with angle 60 degrees. Then minus this equilateral triangle. But how to find the area of the equilateral triangle? If one side of equilateral triangle is A, so we draw the height of the equilateral triangle. This side is A over 2. By Pythagoras theorem, we have the height equal to square root A square minus A over 2 square. This equal to square root 3A square over 4. So which is square root 3A over 2. So area of this triangle equal to half times base times height, which is square root 3A square over 4. So this shaded region area equal to area of the sector plus area of the minor segment. For this one, 60 over 360, which is 1 over 6. And divided by 2. So this equal to 2 over 3 pi. This is also 2 over 3 pi. This equal to square root 3. So the answer is 4 pi over 3 minus square root 3. Answer is A. Question 2. There are 6 points on the same straight line. M is midpoint of AB. So we just draw the waves like this, mean AM equal to MB. So similarly, N is midpoint of BC. Okay, BN equal to NC. And O is midpoint of AC. So AO equal to OC. The following statement mentioned the relationship between the line segments. Okay, how to determine which one is correct? From this diagram, we let Cn equal to x. So Bn also x. We let OB is y and OM is z. Since AM equal to MB, so AM equal to y plus z. O is the midpoint of AC, so we have AO equal to OC. AO is y plus 2z. And OC is y plus 2x. From here, we can get z equal to x. Z is MO, X is Cn or Bn. So we have OM equal to Cn. Okay, so answer is B. Question 3. We need to know flow function. Flow function x means the largest integer no more than x. So from this definition, we know flow function of x will less than or equal to x, but greater than x minus 1. So from the equation, we know this one will less than 5x minus 2 over 3, greater than 5x minus 2 over 3 minus 1. So first, we get this inequality. For these 3 parts, we times 6 to each one. Then we can move the denominators. This one times 6. So here we get 2 5x minus 2 minus 6. This equal to 10x minus 4 minus 6, so minus 10. The middle one times 6, we get 3 7x minus 31, which is 21x minus 93. The right one times 6, we get 2 5x minus 2, which is 10x minus 4. Okay, next, we minus 10x from these 3 parts, minus 10x. So this equal to 11x. Then we plus 93 to these 3 parts. So this is 83. This equal to 89. Then divided 11 from these 3 parts. This question told us the equation has 2 distinct solutions. Here we get x in this range. But how to determine the value of x? From the original equation, because the flow function is always an integer, so this part should be an integer. 7x minus 31 over 2 is an integer. We let this integer be k. So 7x minus 31 equal to 2k. We can get 7x equal to 2k plus 31. From here, we can see 7x should be an odd number. So from here, we times 7 to these 3 parts. Write these two fractions in mixed number. 7x is an odd number. So between this, we can get 7x will equal to 53 or 55. So x equal to 53 over 7 or 55 over 7. One is alpha, the other one is beta. So we can find the floor function of alpha plus beta, which equal to 15. So answer is C. Question 4. Given P and Q are in terms of A. From the following statement, we need to compare P and Q. We use Q minus P. Q minus P equal to a quadratic function. Simplify it, we get a squared minus a plus 1. A can be any number. So here we use a completing square. We can get this equal to a minus half square plus 1 minus half square. So which is a minus half square plus 3 over 4. This is a square. It's always non-negative, then plus 3 over 4, so which is greater than 0. Q minus P is always greater than 0. So we get Q greater than P. P. Answer is B. Question 5. We need to find the probability of the equation has two distinct real roots. For quadratic equation, its discriminant equal to b squared minus 4ac. If d greater than 0, we can get two distinct real roots. D equal to 0. The equation has only one real root. D less than 0, no real root. So this equation has two distinct real roots. The discriminant will greater than 0. So b squared minus 4ac. Here is a squared minus 4b greater than 0. A, B are the values on the dice. A can be 1 to 6. B also can be 1 to 6. 6 times 6 equal to 36. So there are 36 possible outcomes. For case A equal to 1, B equal to 1. A squared is 1 squared, minus 4b is minus 4 times 1. This is negative 3 less than 0. So the value of discriminant is negative. This case, b is 2. 2 squared minus 4 times 1. This is 0. Value is 0. 3. 3 squared minus 4 times 1. This is 5, greater than 0. When A equal to 4, 5 or 6, because 4, 5, 6 is greater than 3. So the discriminant will be positive. For the second law, this value, because A is still 1, B is 2. Compare with this one, we know this should be negative because B is greater than the value of B in this case. So this is negative. Okay, this value here is, this one is 0, so this should be negative. You can check. A is 2. 2 square minus 4 times 2. This equal to negative 4. Less than 0. So this is negative. A is 3. 3 square minus 4 times 2. This is 1, greater than 0, positive. So the remaining will be positive. For the third row, this one should be negative. Negative. For this one, A is 3 squared, B is 3. 9 minus 12 minus 3, less than 0, negative. A is 4. 4 squared minus 4 times 3. 16 minus 12, 4, greater than 0, positive. For the remaining are positive. Fourth row, negative, negative, negative. For this one, 4 squared minus 4 times 4, which is 0, 0. Then positive, positive. For the fifth row, negative, 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 negative. When A is 5, B is also 5. 25 minus 25, greater than 0, positive. So this is positive. The last row, negative, 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 negative. A is 5. 5 squared minus B is 6, which is 1, greater than 0, positive, positive. Among these 36 possible outcomes, let's count how many values are positive. 4, 4, 2, this is 10. 1, 2, 3, 4, 5, 6, 7. So there are 17 positives. So the probability equal to 17 over 36. Answer is C.